Rod and I are happy to be here. I'm actually based here in New York, and Rod is based in San Francisco, in our where our corporate headquarters is located. So yeah, we're Gradient. We're a San Francisco-based climate tech slash heat pump manufacturer. We company was founded back in 2017. Our founder is Vince Romanen. He's a PhD from Berkeley, and spun off of other lab, and we formed Gradient in 2022. We launched our flagship unit, which we'll touch on today, but it's a heat pump that's rated for more moderate climates. Rod, you want to go to the next slide, please? And obviously, you met us. And go to the next one. So again, we're a socially conscious, mission-driven company, and our mission is quite simply to provide, as we say, planet positive building comfort. We understand that clean air and comfort is a right and not a privilege, and we take that very seriously. Next slide, please. And obviously, we feel that the way to do that is through heat pumps, which are a huge part of the future of HVAC in terms of sustainable options. Why? They're 3 times more efficient. The incentives, fortunately, the government is putting its money where its mouth is, and in the form of $22 billion in incentives, as well as federally, as well as local incentives, utilities, and the full gamut. And they're obviously more planet friendly, and there's better air quality. Now, what are the options, or what are the gaps? However, the obstacles rather than the gaps, widespread adoption in older buildings. There's a higher initial cost, which we'll touch on today in our presentation, which includes, fees and having to hire professional HVAC contractors and so forth. Infrastructure limits, right? Ducting in older buildings, electrical limitations in older buildings, and even some newer buildings, which make these prohibitive in other instances. And I touched on it earlier. Permitting can be very expensive and cumbersome. And at this point, there continues to be more of a shortage of skilled labor, particularly this type of labor in the HVAC industry, which is an industry-wide problem, as I'm sure many of you know. And then there's other issues, asbestos and other issues, things that you find when you open up that Pandora's box, which aren't always good. Rod?
Yeah, thanks, Brian. So I'm going to start telling you a little bit about our product here. We're going to spotlight our all-weather 120 volt product that's coming out at the end of this year. And this product, it begins and ends with our customers and the end users, as well as the installers. And so I'm going to go through some of the details of the product and give you some insight into how we developed it as well. So naturally, you're probably familiar with our flagship product, which revolutionized what's possible to install in your window and plug and play. So it was the first over the window saddle heat pump ever designed and sold. And so now we took that architecture and we've taken it to the next level, really, with the all-weather solution. And so about 2.5 years ago, we had a chance to go and interview a number of residents in New York City housing apartments to get feedback on our first product and insights into what we should develop for our next product. So I really think that it's really important to note that we really wanted to get as much insight from the end user as possible. So what that looks like now is a modular solution that's good for all weather conditions. Our product fits in approximately 50% of the US market of windows. It's plug and play into a 120 volt outlet with a 15 amp breaker at least. It's extremely quiet, down to 38 decibels at a 1 meter distance on the indoor side, which is just remarkably quiet compared to any window air conditioner on the market today. And it's extremely efficient. At at all temperatures. So I'll get into that a little bit later. We are offering a MERV 13 filtration solution that is good enough for schools and beyond. And we are just overall 95% lower in direct emissions. And another customer of ours is the installer, the people who go in and retrofit buildings, and we've taken a lot of time speaking with various technicians, installers, contractors to try to get their feedback as well. And in the end, I think what we've designed is quite incredible. It's a less than 30-minute install with no permits necessary, no licensed contractors or anything like that. And we've been able to prove this out in the field as well. And it's less maintenance than your typical mini split or multi split, which is we're really proud of what we've designed here. And then beyond that, because it's a connected device, it enables things that haven't been easy in HVAC in general, especially with large multifamily buildings. So we've been running some pilots with demand response and cloud-based energy management, as well as working hard on indoor air quality control, because these are smart Wi-Fi connected devices. So getting into some of the specifications of the product itself, you'll see the dimensions on the upper left. It's about 2 feet by 2 feet square on the inside and on the outside. The indoor unit only comes into your room about 8 inches, and the outdoor unit is quite a bit larger. It holds most of the refrigeration, and it's 14 inches deep on the outside. The overall weight is, excuse me, it's about 125 pounds. So 2 people can actually very easily lift this. We put a lot of thought into the ergonomics of the lift and install. And I mentioned the noise. I think it's best in class noise for this type of a product. And I've mentioned the power, and I'll get into some of the features in a moment. We have heating, cooling, fan only mode, as well as we're developing some smart modes as well. And then it's a 9,000 BTU per hour in cooling and in heating heat pump. And then most importantly, at the bottom right here, you can see our energy efficiency, which these are still preliminary numbers, but it's not going to get worse than this. It will likely get better when we finally publish our final numbers here. But you can see in heating mode at 47 degrees, we have a coefficient of performance of 4. So for every 1 watt of electrical energy in, we get 4 watts of heating out. And then at 17 degrees, we're still at 2.6. At 5 degrees, we're at 2.35, and all the way down to -7, we're still close to a COP of 2. So as I mentioned, it's a connected device. This was designed with the contemporary user in mind, people who are on their phones frequently and can like to control devices in their homes with their phones. And of course, we added scheduling and setting different modes and temperatures. And then for larger buildings that have a building management system, we've also enabled BACnet on this product, which is a change from our previous flagship product. Now, I think Bryant mentioned this a bit earlier, but we at Gradient really think that electrification is the only way to decarbonize homes and buildings. And the only way to electrify is with heat pumps. As you can see in this slide, space heaters are really the only other way, or electric baseboard heaters are the only other way to electrify heating in someone's home. And you can see that 9,000 BTU heat output for a space heater consumes 2.6 kilowatts versus a heat pump like Gradient at 9,000 BTUs could be as low as a half a kilowatt. So I think this is needless to say, heat pumps and our product in particular are the only way to electrify buildings in a sustainable way, as we know that the grid will be overloaded very soon as we electrify everything. And if we start to try to electrify with electric baseboard or space heaters that at best have 100% efficiency versus heat pumps that are closer to 300% in most cases, it's kind of a no-brainer. If we have to electrify buildings, we have to do it with heat pumps. And then thirdly, the safety aspect. It was really funny. One of the first interviews we did in New York City housing, as soon as we walked into their home and we brought the device into their home and we asked them questions about it, immediately this resident turned to us and was like, "I don't want electric. Get this electric thing out of my house. It's gonna burn down my house." And then we had to like calm her down and say, it's not the electric you're used to. This is a heat pump. And I think in the end, like even after trying to educate her a bit about how heat pumps work and how it's similar to your refrigerator or your air conditioner, it's not the electric heaters that you see burning down homes. I think we calmed her down, but in the end, she was still like, "I don't want electric. I just know electric is dangerous. I don't want it." So that was kind of a funny experience, but that's probably represents some percentage of the populace that thinks electric in general is dangerous, so there's some education needed there. And then when you look at sort of the install costs and the overall costs when you're trying to decarbonize a home and decarbonize it with a heat pump, you can see sort of a simplified comparison of a gradient unit versus a mini split. Same size mini split, same size gradient, and you can see the overall cost to install one gradient versus one mini split. Very conservatively is $2,000 cheaper. What we've seen, depending on the state, depending on the contractor, mini splits can go upwards of $15,000 to $20,000 for an install in a single family home, let alone in a multifamily home, where things get a lot more messy when you're trying to install mini splits or multi splits or even VRF systems that typically you want to try and put them on the roof, but that doesn't always make sense. And sometimes you want to put it on a balcony or in various places. So the costs just start to really rise with the traditional heat pumps that we have in the market. And so Gradient has developed a product that is really plug and play. We still do need installers, but it's a 30-minute install for each heat pump. So let's say like a 5-story multifamily building, rather than it being a months-long or year-long process to install a heat pump involving contractors and subcontractors, really you can decarbonize the heating and cooling of a building in a matter of days, as opposed to weeks, months, years. So yeah, just to mention a few of the features that in case I miss anything, we did mention less than 30-minute install. We've really been seeing 15-minute installs, and then no contractors needed. Designed for cold climates, 9,000 BTU of heating and cooling. AC and heat pump without any resistive heating for space heating, variable window depths to try to capture as many windows and buildings as we can. And then we have variable speed compressors and fans so that we can modulate to the load inside of the home. And then, of course, very energy efficient. We've also, this company started really with design, and we initially were thinking, oh, we should make something really beautiful that like is just like a statement piece in someone's home, and maybe it takes up a lot of the window, but it has to be just stunning. And then quickly realized that people don't want to see their HVAC. And so in the end, the design philosophy was actually like, be invisible as much as you can, be a part of the home. And so that's where we landed on this saddle design that hangs over your windowsill, only takes a few inches of your natural light, and you have your window still operable as well. And yeah, another great thing about our product is it's a lot easier to maintain than a mini split because you can just uninstall it in 15 minutes and put in a spare in another 15 minutes and work on a unit outside somewhere else, away from the resident and not disturbing the resident. And I didn't mention that, we are initially, we really wanted to use propane as our refrigerant. As many of you probably know, the global warming potential of propane is probably as close as you can get to CO2 without being there. And unfortunately, regulations in the country right now don't allow for propane. So the next best thing that's available and has a good enough performance is called R32. And that global warming potential is about 3 or 4 times less than what's typically used nowadays, which is R410A. So we're using the best possible planet-friendly refrigerant that is within regulations right now. So just to briefly mention also what the requirements of the window are. We can fit through windows that have a sill-to-sill depth of 10 inches to 18 inches and a window width of at least 26 inches. And you want the product to also have enough space below the windowsill of about 21 inches. And
So,
maybe I'll
yeah,
pass it on to Bryant
yeah,
to talk a bit more about it.
yeah. So again, a lot of people ask. Obviously, I lead sales. I'm speaking to most of the customers these days, and who's your biggest competition? And at this point, it really is mini splits because obviously they've captured the market and have done a great job in doing so. So when you compare us to a mini split, as Rod said, I don't want to repeat. He went into a lot of this, but the benefits are really come with the ease of installation. We we present our product as a product that has the comfort, convenience of a mini split with the ease of installation of an air conditioner. That's really what it boils down to. And again, the installation is really where we win. Again, hours of on-site professional labor, meaning a licensed HVAC technician. And to be clear, Rod touched upon this. We still partner and want to partner with contractors to do our installations. It's just that it's not as time consuming. And from their point of view, they can do this job, charge less, still make money, and be in and out. So there is a home for contractors. We do have a contractor program that we're looking to build, and we have a ton of contractor interest. So we're not looking to remove them from the process at all. But from a cost standpoint, you don't have to pay for a professional HVAC service. Again, we talked about permitting in New York. We've confirmed with the Department of Buildings that we don't need to file for permits, and we imagine that to be the case in other cities. Same thing with inspections. There's no design fees required. So again, just these are things that we talked about as far as where you really see the benefit and the cost effectiveness of our product. Really, the installation boils down to, one hex key, 2 lay people, and 15 to 20 minutes. And that's what we've, been seeing so far. Next slide, please. So again, we talk about the installation. Here's what it looks like. This is a video. And Rod, could you mute this if it's not muted? Very simple installation. The unit comes in one piece. The bracket will be installed. You put down some insulation at the bottom. Bracket goes in very easily, snugs to the window. 2 people lift the unit, take it over to the window. You see there's 2 little prongs at the bottom. If you see them, when that snugs to the wall on the inside, carry the unit over. Again, it's 125 to 130 pounds. It clicks onto the bracket to where it cannot fall out the window. Lower it down with the handles, put the top on. Insulation, which again we provide on the top to seal the window, and that's it. That's the insulation. So one of our biggest wins so far, by far, is this NYCHA Clean Heat for All challenge that we won. So again, as I mentioned earlier, and as Rod touched upon, we are based in San Francisco. Our flagship unit, which we referenced, came out in 2022, and was rated for moderate climates like San Francisco, could heat down to 40 degrees. We got a lot of positive press and accolades from this unit. We were recognized in Time Magazine, a New Invention of the Year, Fast Company, and a few others. And it caught the attention of NYCHA and said, hey, we love this unit. We need to decarbonize because of Local Law 97 and other initiatives here in the city. We love this unit. A central system isn't the right fit for us. So if you could come up with this same in-unit solution, there's a couple of caveats, okay? It's got to be heat rated for cold climates, so it's got to heat down to -7. It's got to be 120 volt outlet, and you got to do something with the condensate. And if you can do that, we'd love to partner with you. And thus we came out with the all-weather 120 volt unit, and which checked off all those boxes. I see someone asked about condensate, which we'll touch upon as well. And as a result, they awarded us 10,000 units that we're going to be installing over the next 4 years. We started with our initial, and as obviously Governor Hochul with the announcement. Next slide, please. We started with our initial installation of about 32 units last year, so it's gone through the full heating season so far. So again, this Clean Heat for All challenge is basically similar to a challenge that NYCHA had in 1996, which was for super efficient refrigerators, SERP program. So as you all know on this call, a refrigerator is basically a heat pump. So it's kind of come full circle here with our units now. So as you can see, 1996, and then our units being delivered in 2023, November of last year. And we actually left with a prize, a trophy, and that is the radiator that we ripped out of each unit. So we talked about the ease of installation, right? Really took 20 minutes, and Rod will talk about how easy it was, how quick and easy it was for us to train their technicians. But the only thing that took a little bit more time was the fact that NYCHA had to remove the radiators from the window of each unit. So that took the bulk of the time. And this was, again, one of our trophies that we're happy to remove. And now Rod's going to talk a little bit more about the details of NYCHA and the installation itself.
Thanks, Bryant. So yeah, as Bryant said, we were really excited and happy to be able to serve NYCHA as one of our biggest and first customers for the all-weather. And as a part of this Clean Heat for All challenge, we had to perform an early demonstration where our units will be running in this building, NYCHA building, for about 1 year to see all the different climate conditions in New York. And so here's a picture right after we installed of a few of the units, but it's really basically half of this entire building, which is a 6-story NYCHA building. And we installed 37 of them in really less than 4 days, which, I mean, if you can imagine decarbonizing 12 apartments in a New York-like multifamily building in any other way would have taken far, far longer. So yeah, just to share a few photos. There's like a nice community garden here with the residents that they were happy to have these products as well featured in their garden, which was nice. And then you can see the New York skyline in the background, really representing how much New York has lifted up our company as well, and how grateful we are for the city to be pioneering these kinds of technologies. And then here you can see, actually that's Bryant on the left. with our CEO, Vince. This was actually the first unit we ever took to NYCHA. And we were doing just a demonstration of an early prototype for residents about a year ago now. And again, with the beautiful New York skyline and Queens in the background here. So these are a couple of the residents that allowed us to use their photos, and they're just so excited about their product. As soon as we installed them, they started decorating them and putting things on the shelf, and they were just really, really happy. So as I mentioned, from the install to the residents, all of this is at the heart of what we do at Gradient and what we want to do. This is really about people and the planet. And so you can see here, like I said, it took less than a week to install 37 units in 12 homes. The training of the team was really like an hour where we just showed them an install with our install manual there and handed them each an install manual. And so the NYCHA's heating and cooling team basically learned from us and in an hour, and then did all 37 units all by themselves. And they a few comments from the install team were that they really liked some of our latching mechanisms we have in our product. Really put a lot of thought into, okay, when does the unit need to be constrained, and when is it okay if it's a little floppy? And we've like really nailed that down now and refined it to the point where you put it in this different configuration and it's very rigid and easy to pick up and install. And that really showed in the comments from our trainees at NYCHA. And then the residents in this building were quite diverse, came from all kinds of backgrounds, leaned towards elderly. And so we really wanted to learn as much as we could from the elderly folks and how they would interact with our product and what's easy, what's hard. And we still continue to get great feedback from them. And some of them have mentioned how, these radiators got so dusty and dirty, and it's like almost impossible to clean. And so they love that this unit is like very easy to clean, so they can breathe better. There's not this like dusty air around them. And then also the filtration, they appreciated the filtration for that reason as well. And then many of you in New York and elsewhere probably know that there's a habit for these steam radiator systems to be oversized to the point that you have to open the windows even in the coldest days. And then you're just pumping money and heat out the window. And the residents are just super uncomfortable. Like, you're even with all the windows open, I've been there, I know, you're sweating in the middle of winter in these homes. And so another transformative thing of this technology was really that you for the first time in their lives, some of these two residents actually on the right here, both of them have lived in NYCHA housing in these apartments for 40 years. And this is the first time in their lives they've had climate control in their apartments. First time ever. It's transformative, and they've been extremely happy for that alone. And then a funny one of these two women's friends as well. I visited her once, and she told me, I asked her, "Oh, how is everything? Is it all good?" And she's like, "Rod, in the heating mode, one day I came out of the shower and I walked by the unit and I felt how hot the air was, and I was like, I don't need my hair dryer anymore." And she started to just dry her hair in front of our unit. And that was just it was such a confirmation for us, because so many people also have this misconception that heat pumps don't pump hot air, that they're kind of cold or lukewarm. And the fact that she's using it to dry her hair is just a testament to how good our heat pump is, I think. And so that was also very gratifying to hear. Now, as far as performance goes, none of this is like published or publicized really yet. So we're just giving you our own gradients insight because we have data on our back end. We can communicate with all of the products, and we learn. We've been learning throughout this demonstration period ourselves. Uh, and NYCHA, NYCERDA, and NYPA will be publishing various studies and the results of their studies as well. And they've given us permission to share, what we've done and our own learnings. So I'll get into the performance in a little bit, but firstly, I want to spotlight one of the most innovative technologies that we've put into this product, namely how we deal with condensate and meltwater. So heat pumps, as maybe many of you know, produce condensate in the summertime and what's called meltwater, where ice builds up on the coils on the outdoor side and then melts away. And up until now, really, the only way to deal with that water was to either plumb it away or drip it onto the floor. You can think of like a typical window air conditioner that's in someone's window that drip, drip, drip. In the summer, you'll hear it dripping, and in the winter time, this now could become a hazard if ice builds up on the floor or on the facade of the building. People could slip, people could fall. And so NYCHA asked us to innovate and to figure out a way to remove condensate in a way that was not hazardous, essentially. So we developed what we call our water atomizer. So you can see in the photo at the top right here, there's 3 holes at the bottom of our outdoor unit. And if you look carefully, you can see a mist coming out of those 3 holes. So any water produced by our product gets atomized. And what we mean when we say atomized is it's just tiny droplets that get blown away in the wind. And so this has been working remarkably well and has I think completely solved this issue and concern of ice buildup on the sidewalk or on the building. And we've designed it very carefully so that the atomized water actually gets blown away from the building because our outdoor fan actually picks up the atomized water and pushes it away from the building. So really proud of the team and the innovation here. And then so just now to get into a little bit of the performance data that I can share with you here, just looking at one outdoor temperature. So at 17 degrees, so below freezing, based on our experience at NYCHA, you can see at the chart at the bottom right, the coefficient of performance of the boiler system that was at NYCHA before, or still is at most NYCHA facilities, is about 60%. The NYCHA's requirement for these heat pumps at 17 degrees was a minimum of 1.85 and a maximum of 2.35 preferred. And so we, in our lab, we blew that out of the water already, and it was a COP of 2.6 at 17 degrees. And then what we're seeing in the field is actually it's above 3, like even up to 5, a COP of 5 at 17 degrees we've seen. Of course, this is all initial data, but the reason that we're able to get even higher efficiencies than what you're seeing in the lab is because our units are so smart that they modulate to the load of the building, the load of the apartment. So you can see the compressor speed at the top right. The compressor basically modulates down when there's not as much load. And so when you have a lower compressor speed, you have a much higher efficiency and you're drawing much less electricity. So we're really proud, not only that we met NYCHA's expectations, but we met our expectations. And then we also blew our expectations out of the water because of the modulating inverter technology. Okay, so then just to sort of one of the studies we did internally again was just now that we have some data from this NYCHA demonstration, what does that look like when you look at a natural gas boiler or a fuel oil boiler replacement? And what does it look like when it comes to the cost as well? So electricity costs as well as like how much money you're spending on your heating or cooling. And so here you can see basically the cost reductions at various different stages. So on the left, you can see COPs in different conditions, general COPs of what we've been seeing in the field. So in moderate temperatures, it ranges from a COP of 3 to 5.6. In colder temperatures, or in the coldest days that we've seen, it modulated from 2.5 to 4.7. COP. And so based on those coefficients of performance and the cost structures that are publicly available for New York City buildings and homes, and so not even NYCHA, not considering NYCHA's case, because we're not trying to say anything about NYCHA's pocketbook at all. This is just trying to extrapolate the performance and see what it looks like for other New York buildings. And so based on that, you can see the cost reductions in green there. So for a natural gas boiler, it's a little bit more moderate savings, but still between 29% and 62% in moderate climates and 15% to 55% in cold climates. And then for a fuel oil boiler, you'll see it ranges in moderate climates from 59% to 78%. And that in colder climates from 51% to 74%. So, our initial conclusions are really that the energy cost of gradient units is about less than half the cost of the displaced fossil fuels that we're replacing. And then we also took a closer look at total cost of ownership versus maybe traditional HVAC. In this particular case, we're comparing to a building, like a multifamily building in pre-1970 with natural gas steam boiler and a window air conditioner. And so our analysis shows, that the annual total cost per square foot for a steam system in a multifamily building is about $2.41, and for a gradient system would be just under 70 cents per square foot. So again, that confirms our other data as well, that it's about a 70% reduction in annual costs as well. And and then there's of course the savings from ongoing maintenance as well. And I'm sure that people probably have questions about this, so we can get into it a little bit more if anyone's interested later. But I'm going to pass it on to Bryant to talk a bit more about gradient in the spotlight as well.
Yeah, we're actually going to wrap it up. I mean, I guess the net result of all this great information that we consider to be great, we hope you all do, you too, is just we've gotten a lot of recognition, widely celebrated, award-winning product that's people have been taking note of, which is great. And again, we thank Passive House for the invitation here as well. But beyond, locally, we actually were awarded a Department of Energy grant from the government, which was going to enable us to move our manufacturing, which is currently in California, again in San Francisco in our headquarters, as well as another location in Los Angeles, and move that to one location in the Midwest area. We're targeting Michigan, Ohio, perhaps, and in conjunction with that announcement, we were actually invited to the White House for a demo day. You see Vince, our CEO, looks a little bit different than he did installing a unit, but there he is on the right. And then obviously President Biden to his left, and again some of the other awards that we we're recognized with. And again, it's just really a testament, we think, to the technology, the problem that we're solving, and hopefully the potential, in the future for expansion. Last slide, please. But at the end of the day, it's all about, as we said, trying to bring this technology to individuals, to people, right? That's really what matters most. And so far, it's been well received. Rod got into some of the feedback from NYCHA. I've been there myself, and I can tell you firsthand that people are, the technicians were impressed with how easy it is to install, and the residents were happy with their initial results. So with that, we will turn it over to any questions you may have, and be happy to answer.
Fantastic. Brian and Rod, great job. That was really excellent and super exciting. Congrats on the NYCHA award as well, and the 10,000 radiator trophies you have coming your way. That'll be
we're trying to get one. I mean, I was actually out in San Francisco last week, and I usually take a couple of things back, but I couldn't figure out how to take a radiator back.
They're really heavy.
They're a little heavy, huh?
They're like 300 pounds.
Right.
So
That's amazing.
I think I passed the JetBlue weight limit of 50 slightly. So I'm gonna figure it out.
That's awesome. Also, thank you to Gradient for being a champion sponsor of Passive House Accelerator and supporting our work. We're really, really grateful for that help as well. So as I expected, we have a lot of interest and questions in the chat. I think maybe has broken a record here. We've been hovering at around 100 people this whole time, and
I do
lots
have one,
and lots of questions.
I do have one more thing to add, which I should. There may be a question. So as far as where the product availability is, we are still in pre-sale mode. So the product will be widely available starting the end of this year, Q3, Q4, more late fall, early winter. And again, we're in pre-sale mode. The MSRP is $3,800, which we are currently selling direct. Anyone that is interested, we've currently had them signing non-binding letters of intent, which basically helps to ensure availability for our first run, as well as locks in the price. So if that question comes up, that's where we are with the order process. So.
Awesome. Thank you. And I think we have you both for another like 25, 27 minutes, right? We should wrap up at about 15 after the hour. Yep. So let's dive in, and we'll try to be as efficient as possible with these questions so we get through as many as we can. So let's start with George Noggles. You had a couple of questions. I think one was answered, but you had one about tax benefits. Maybe you could share. I think I saw it.
Would you mind reading it from the chat? It's hard for me to watch if I read from the chat. Go ahead.
Of course, George, no problem. So, and maybe you can elaborate a little bit. So the question was specifics regarding IRS current and likely future tax benefits for your product and max amperage, ?
Well, I'll take the first part on the specific. The specifics are that, may not answer the question specifically, but we're working towards, we fully expect to be eligible for all IRA rebates. I mean, part of the challenge is that we are brand new, not only we're a brand new product, we're a brand new category. And so that affects us, our eligibility for IRA rebates, as well as in New York City and state rebates for local Con Ed utility rebates and the clean heat program, simply because they don't recognize the category yet. They see us as essentially a window AC, which isn't eligible for rebates. We're a heat pump. So we're working very diligently. We have a very talented senior VP of policy who's working very diligently to have us recognized. So, but the short answer is we do anticipate being eligible for all IRA incentives as we get closer to launch. But for now, it is still a work in progress due to the circumstances that I explained. The second part about amperage, Rod, do you want to take that?
Sure, yeah. So also just to add on to Bryant, Gradient is also leading the way and is in very close communication with all of the different federal agencies needed to qualify. So we very much anticipate that we'll be ready with all of those incentives at launch as well. So in terms of max amperage, the product is rated to not exceed 12 amps. But because of that, we recommend a 15 amp breaker and no lower. Yeah.
Great. Thank you. Okay, next up is Scott Williams.
Great. Thanks so much. Just a couple questions with regards to integration with the window systems. I see that in all the graphics that you provided is all slider type. Just wondering how that integrates with the window to reduce air leakage and potential water ingress. Because as soon as you disengage a slider and slide it up, then the bottom and top seals are no longer being compressed for that weather seal. So just wondering, and also as an add-on to that, is there any work that you're doing with window manufacturers to provide that integration to better seal that window system? Thank you.
Yeah, I can take that one. Thanks for your question, Scott. We've put a lot of research and development and time into sealing. Obviously, we're a heating and cooling system. If we leak a lot of outside air into the building, we're working against ourselves. And then NYCHA themselves actually put a very difficult requirement for us to meet, which was we had to be less than 4.5 cubic feet per minute at 75 pascals of pressure difference between the indoor and outdoor. So for those of you that are familiar, that's very like commonplace for like air leakage testing in buildings. And so we worked really hard, and this is a hard problem to solve. We iterated like I don't even know how many times at this point, so many prototypes testing in our lab, and really proud to say that, even at the time of demonstration, a third party came in and did blower door testing with our units installed and with our units not installed. And our average was less than 5 CFM and acceptable to NYCHA. So really proud of what we've been able to do. I think to your specific questions about how windows, when they slide down, there are gaps. We provide specific foams. We've specifically designed for this type of a window that basically are rip away to be the exact size, and then you fold it over itself in and on top of the window and into the space between the windows. And actually, we've developed it so that it creates a double seal on that as well. So our team has done an awesome job getting there. And I think you'll be really happy once you get a unit and you see it.
And to answer your second question, it's very early, but we are sort of kicking the tires on working with various window manufacturers as well.
Great.
Yeah, we're always interested in these kinds of partnerships. You may have seen in Source 2050 is doing a small pilot with our flagship product and an Alpine Windcert installed like on top of it. And so that is another way that we're just happy to work with anyone that's interested in decarbonizing buildings, really.
Excellent. Okay, so George, your next question was about the refrigerant, which later got answered. It's R32. So let's jump to Caleb Crawford.
Yeah, competition. I was like browsing around, and it doesn't seem like you have any competition. Since I'm represent a state authority, and we're desperately trying to seek new ways of electrifying schools. The peculiarities of the procurement process for state agencies, which you're probably going to, NYCHA, because it was a pilot program, you were able to bypass that, right? Yeah, figure out how to license your technology. Somebody's going to rip you off. Don't worry.
Full disclosure. There is a competitor out there. It's a company called Media. They're based in China. Like I don't bring them up unless someone else brings them up. But I'm surprised at how often they don't come up. But they are. You research NYCHA, you look at clean heat for all, you see that the challenge was awarded to us and MIDEA. But we are the original inventors. I mean, our two co-founders, you know, own the main patents on this. So this is you know, a gradient product. But again, we do have a competitor out there that has a similar product, and they are, as someone said, they are on this NYCHA project as well. But from where I sit, I don't. When I speak to customers, we're mostly talking about mini splits as opposed to the other heat pump. In fact, I'll share this. I was on a panel with our main contact at NYCHA a few months ago, and he commended us because, yeah, obviously we're a small startup. He commended us on our marketing efforts, you know, small team, and he said, you know, versus this huge $4 billion Chinese company. And he said, quote, everyone in the residents as well as the people involved, you know, techs, they don't refer to them as the heat pumps, they refer to them as the gradients. So we've definitely done a really good job of getting the word out, which we touched on today.
The Band-Aids of heat pumps, right? That's what you want to be.
Exactly.
I think just Caleb, also to thank you for the question, and we are really interested to learn more about how we can get into schools as well, and if we are a good solution in schools. So I would be interested to talk to you after this if you're open to it. And you know, I think there is competition coming. Not only MIDEA, others are realizing that, you know, this is a great product and we need more of them. So it's really validation for us more than anything. And I still think we have a lot of differentiators that make us better in a lot of ways. So bring it on. That's what I say.
Yeah.
Awesome.
Why Mitsubishi has such a big share of the heat pump market is because of the quality of their product. And so that's how you continue to distinguish yourself. So
yes, sir.
But yes, I'd love to talk to you more about it.
Great.
Cool. Thanks, Caleb. All right. Next up is Howard Stern.
Yeah, hi. I'm glad you did the 120 volt version, and I'm really glad that it's wider now, that the saddle opening is wider, because that's been a problem with, I think, the first generation. I have two quick questions. What do you do about bathrooms, like small bathrooms? And, you know, sometimes they have windows, sometimes they don't. Even if they do have windows, you're not really going to put one of these units, you know, in a wet area. You know, how do you deal with like that and humidity and stuff like that? And then the other question, real quick, is what do you do about casement windows? Do you have an option for casement windows yet?
Yeah, I can touch on that. So yeah, firstly, thanks for the comment, and we are really trying to make the product as flexible as we can so that it can go into as many homes as possible that want it. Your question about bathrooms, depending on the size of the bathroom, there's nothing preventing someone from putting a unit in the bathroom. And if there's a window, the humidity won't affect it. The unit can handle that. It's totally fine. What I'll say just as an anecdote is that NYCHA decided not to put anything in the bathrooms. And they believed that these units would keep the bathrooms warm enough. Now, what we're seeing in the field is that the bathroom, it kind of depends on the person. So even me personally, like, I don't like a cold bathroom. So like the ultimate luxury for me is radiant floors in my bathroom. But for the NYCHA residents, I'd say about like less than 10% of them that have these units have said anything about the bathrooms being cold. And then when we go into their homes, we realize, oh, their windows are open in the bathroom too. So it might even get colder. NYCHA is trying to figure that out for themselves. There's some really like easy and cheap solutions to like a towel rack heater kind of thing that would definitely handle a space like a NYCHA bathroom that are quite small. But anyway, that's just a little bit of an anecdote there. And then regarding casement windows, we have seen a few examples of people trying to install encasement windows. And, you know, what it really would require is that you remove the window, install it, and then assuming that there's enough space for the window to close, then it would be okay. And NYCHA themselves are making efforts towards replacing the windows when they install these units, and have gone out for quotes basically to replace to a casement window that can accommodate these products. So
thank you.
Excellent. Thanks, Howard. All right, next is Bill Lyons.
Hey, thank you. This is an amazing product. I've been following it for a while. I have one question and one comment. Question was, what would this heat capacity be at, say, 5 degrees? If that's something you've got fairly easily. And the comment is 26 inches is a non-starter for, I think, a lot of windows that have multiple openings or multiple frames within one unit. 22 inches, 24 inches. For future iterations, can the outside unit be narrower and taller so it can slide out through? I don't have a single window in my house that is wider than 24. And I think a lot of the multifamily buildings we work in have similar, 3 frames per opening, and they're all 22, 24 inches, especially if you have a vinyl. If you've redone vinyl, you lost an inch or two on each side already. Thank you.
Yeah, thanks, Bill. I think we're always looking for more data. So we just go based on the data that we have and the data that we can find. So we've done our own internal studies about window sizes. And then we've also referenced existing federal window databases. So if you have more, please share it. We're always open to learning more and to adjusting our designs to fit as many windows and as many customers as possible. Then to your first question about 5 degrees, right now the preliminary data, which like I said is a bit conservative, at 5 degrees we have heating capacity of 7,200 BTU and efficiency of 2.35, a COP of 2.35.
Thank you. Sounds good. And can I, real quick, is there any plans, could you plan to have a unit that slides through a sleeve, an AC sleeve? That would be an interesting application.
Yeah.
Thank you.
Thank you. I'm taking notes of all of those. We've had a couple other customers in New York suggesting that, and depending on the sleeve, it could work with this solution already, but it's something that our engineering and product teams are discussing. Yeah.
Excellent. Thank you, Bill. All right, OC Kaminer. Hopefully I got close to the correct pronunciation there. OC, you have a question? I see you there. I'll wait another moment and then I can ask the question on your behalf. Okay, I'm going to go ahead and ask the question for you, OC. So the question is there a way to get the outdoor case in brick colors?
I think a general answer would probably be common because we get these questions all the time. Can we do this? Can we do that? I think to Rod's point, we're constantly researching and trying to figure out what the market needs. Right now, this is our sort of entry product to the market, and there will be future iterations. People ask about sliding windows, other things. So I would say any suggestions that you have, what you're seeing in the market, please forward them our way, and we could certainly take a look at it. But I think for the near future, the product that we showed today is what our focus is.
Yeah, that's great.
Yeah, I mean, we've seen some customers paint their own units too. So
yeah.
When it's yours, you can do it with it as you like.
Yeah. Excellent. Okay, next is Merle Paczynski.
Hi there. Thank you so much for this presentation. It's a really fabulous technology. I'm not sure that you could answer my question. You're kind of on that development and sales side of things, but I'm coming sort of from the social services world, and it's lovely, lovely, lovely that you're working with NYCHA, and that there's such positivity around it. Any thoughts about cost and making this more accessible for low income families, incentivizing for landlords? I mean, you did talk a little bit about IRA. I know the state that I'm in, which is Connecticut, we do have rebate programs for, energizing homes, et cetera. Yeah, is this something that you think about from your end, and to make something like this affordable? Because most of the people in our country, right, if we want to decarbonize, if you will, are poorer folks, quite honestly, living in the kinds of structures that you're working with in New York. So I'd love to hear thoughts about that. That's primarily my interest, although I do have other sort of design questions about sills of different widths and so forth. If there's a sliding possibility, but I suppose mechanistically that could be impossible, but that's also of interest. So thank you.
Well, I'll take a stab at this. I mean, obviously, affordable is a relative term. Like, what's affordable to you may not be affordable to me, and so forth. And obviously, if you're talking about low income, it is what it is, low income. But having said that, I mean, our units are very cost effective / affordable, particularly compared to a mini split. I mean, Rod showed you the numbers. I think we're very conservative. You're talking about being able to buy a unit for $3,800 and practically installing it yourself. You can't do that with a mini split, even a cheaper version of a mini split, when you factor in the installation costs and things that we talked about, other heat pumps, P-tax, and all those other things. So we do sort of pride ourselves on having a unit that is more affordable relative to the traditional heat pumps on the market. Now, having said that, we certainly will keep working to drive our costs down as much as possible. We are working with various other programs besides NYCHA. We're working currently with a pilot program in the Pittsburgh area, which is targeting low-income homes. A lot of our early interest has been through energy solutions providers and utility partners that are, to your point, looking to bring this technology to lower income homes, right? And because of our ease of installation, it lends itself to that. So even if we're not directly saying, hey, we can slash 30% of our units to make it more affordable, the ease of installation lends itself to these programs that, fortunately, we're seeing a lot of utilities lean towards. Again, there's Duquesne Lighting in Pittsburgh has a program that we're partnering with through a third party. We're working with a program in Portland, Boston, South Portland, Massachusetts, rather. So there, the program in Minnesota, and again, a lot of stuff is sort of going through the process and not official yet. But the Duquesne Lighting is pretty much official through a partner company. So again, the way our ease of installation allows us to partner with these other programs in ways that other utilities can't, because the other heat pumps can't, because the budget just isn't there for that.
Yeah, no, that's helpful. Thank you. And we can advocate here in Connecticut too.
Yeah, and thank you for that question.
Thank you.
Yeah. Just to also expand on that a little bit, is just more broadly beyond Gradient. Gradient is a great solution for LMI communities, and we continue to want to focus on them because they're the ones that need it the most, and are most affected by climate change too. But more broadly, looking at the structures of the Inflation Reduction Act and the EPA's programs as well, I'm pretty sure that in writing it says that 40% of the funds need to be directed towards underrepresented communities, which is unprecedented. It's just so cool to see that. And at Gradient we also care deeply about that, and I know that the EPA commissioner, I heard a talk by him recently, and he he was saying that they're only required to do 40%, but they're holding themselves to a 60 to 70% rate of the money going to those who need it the most. And so I really appreciate your question, and it's something we'd love to learn from you as well. This is an interdisciplinary effort, right, to lift up the peoples of the country. So thank you.
Great. Thanks, Maral. And I understand, Rod, that you may have another 5 minutes to spend with us for questions, so that we might be able to go until about 20 after the hour. Is that right?
That could work for me. I don't know about Brian.
Yeah, I'm fine.
No,
I'll go to 20 after.
Okay, cool.
Okay, great. Thanks. No pressure, but we've got a lot of questions. So the next two are actually both Marina and David have a similar question, so or almost the same question. So Marina, maybe I'll invite you to come on and ask it.
Sure. So I was curious about the useful lifetime of this product. I think what I saw on one of your slides was something in the range of 8 to 10 years, which would put it at like a window AC unit's lifetime. Thinking about like further down the line, the amount of like possible waste you might be increasing with, the size of the product and how often it might need to be replaced. Any info you have on that? I know it's very early, so you probably don't have a full picture, but whatever you've got, I'd be curious to hear.
Yeah, so our lifetime, it will be approximately 15 years. Similar to mini split, really. Mini splits in the market today, we use pretty much the same materials, more or less, in terms of the compressor and the fans, and like a lot of the internals are really similar, and so we're anticipating 15 years and we're shooting for 20. But that's to answer that question. And then there was a second question in there, I feel like, or maybe it was an implied question.
Is more just like thinking about the greater waste created.
Oh, yes.
Have to deal with at the end of the life cycle of the product.
So one thing that I'm pushing for our company to think about is, and maybe people on the call here actually could help us with this, is trying to get cradle to cradle certified. So it's a really interesting world we live in, and manufacturing can cause a lot of waste, of course, but we believe that the impact we're having in buildings that are otherwise would not be decarbonized is so great that we need to get this product out there as soon as we can. And in that process, we're also trying to think about how are we creating a product that is not creating more problems than solving. So it's a great question, and I'd be curious to learn from others on this call, including yourself, about how to build a business that's better too, right?
Great. Thanks, Rod. Thanks, Marina. Noah, you're up.
Yeah, hey, Rod and Bryant. Thanks for this fantastic presentation. I was just curious about how you guys are approaching the sales approach. Obviously, you've mentioned some working with utility companies, energy service providers, and other folks. Clearly, there's a bit of like a focus on cities and urban environments. We would just love to hear a little bit broader about how you're approaching the sales and business development.
Yeah, right now, and that's a great question, Noah. Thank you. It's right now, it's a direct sales approach. We're actually looking to expand our team. So if anyone knows anyone in the New England area that's interested, we're looking to hire someone there. So yeah, it's right now, it's a direct sales approach. Myself, primarily, and Rod, and some support with some other departments. And I think initially it makes sense for us to go direct, so we can speak to the customers and know kind of what they're interested in and get that feedback, particularly for our marketing team, as well as our product team, because we've learned some things in the field that we've taken back to marketing and to product and engineering, say we may need to tweak this or that based on what we're hearing. So that's our approach for the, I say, short-term future, to continue to sell direct, but we are looking to strategically partner with other channels, distributors / rep firms. We recognize that that's probably going to have to be the next step sooner than later. I touched on utility energy solutions providers. It really came about from a direct sales effort, and those are the people that seem to have the most interest in us early on. So we kind of go where the business is, but our primary focus right now is on the multifamily market, and obviously those other, like energy solutions providers that we call them, and utilities. Obviously, at the end of the day, they're serving multifamily too, so that's kind of how they found their way to us and vice versa. But to answer your question, it's a direct sales approach now. I'm based in New York, and a lot of our sales are in this area, but we've got a ton of interest from other markets, particularly in the Pacific Northwest, and in the New England area. And those are our next two areas to actually hire someone on the ground. So again, if anyone knows anyone in those areas, please feel free to pass their information along to us.
Got it. Thanks. Yeah, I'm also in New York City and have a double hung window sitting right next to me, so I get it. Thank you.
Happy to place one in that window for you.
Thanks, Noah. All right, Jonathan, you are next. Give you another moment to unmute. Otherwise, I can ask this question. I'm going to go ahead in the interest of time. So Jonathan's question is, I may have missed in your introduction, but what is the lowest operating temperature?
-7 degrees Fahrenheit is the lowest operating temperature for this product.
Great, thank you. All right, Scott Williams, I think we can squeeze in your question, and then we're going to need to wrap up. Scott is not here. So let's how about Shahed? Are you here? No, we are, let's see. I think that we can actually let's have it, rather than just wrap up right away, let's have a question from Martha Sickles. Martha, you had a couple questions. We'll do a lottery here, and you win the last question lottery.
Oh, okay. Thank you. So I do have lots of questions. This is fabulous. I got a presentation from NYCHA, but I just have one question about whether you can go into a common area meter. It seems, I missed the beginning of the presentation. I apologize, but it seems like you're hooking electricity from the units, the unit meters. Is it possible that you can have a setup for a common area meter so the landlord pays for all of the electricity?
Yeah, I think if I understand your question correctly, it kind of depends on the building. One of the great things about our product is it requires zero electrical work. So if a building owner wants to do their own electrical work to ensure that all of the electricity drawn from these heat pumps is billed properly, it's kind of up to their discretion. But we fit with any building, existing building or new, and so.
But currently you basically plug into the unit. So I mean, at NYCHA it doesn't matter because they cover all of the electricity. Is that correct?
Currently, right now we just plug into any wall outlet. So okay. Depending on the customer, they can plug it in wherever they like. NYCHA in particular decided to create dedicated outlets with a dedicated breaker for each of these units. So they did do some electrical work, but that was to their discretion. They just didn't want people to be plugging into the same circuit. But yeah, it's to the discretion of the customer, I think.
Thank you. And thank you for this great presentation.
Thank you.
Thanks, Martha. Well, we are 1 minute away from 20 minutes after the hour. So I want to thank Rod Mobini and Brian Elder of Gradient for this fantastic presentation. Also, thank you to Gradient for its support of Passive House Accelerator. Before we close up, Rod or Brian, would you like to share any final thoughts?
Well, again, just thank you, for inviting us. It was a great crowd, and thank you all for the great questions. and Kim for helping to coordinate this and prep us. Appreciate the enthusiasm, and I'm sure they'll share our contact information. And if anyone's interested in any follow-up questions, we'd be happy to speak with you offline. So thanks again.
Yeah, thank you so much for organizing, Zach and Kim. I think at the beginning of this call, Zach told us that this is kind of our community, and I really feel that. So I think please reach out to us if you want to partner or anything. We're really eager to learn from all of you as well. As much as we've been talking today, we hope to hear from you too.
Fantastic. Thank you both. Thanks, everyone.